We now discuss the solution of a problem from the section Differential Calculus, and the problem is on the value of the derivative of a given function. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is, let f be a differentiable function in the open interval 0 to pi by 2. If the integral cos x to 1 t square f of t dt is equal to sin cube x plus cos x, then 1 by root 3 f prime of 1 by root 3 is equal to. We are given four options. Option A, 6 minus 9 root 2. Option B, 6 minus 9 by root 2. Option C, 9 by 2 minus 6 root 2. Option D, 9 by root 2 minus 6. We are given a differentiable function in the open interval 0 to pi by 2, and integral cos x to 1 t square f of t dt is equal to sin cube x plus cos x. So from this we have to get that from this we have to get the answer of 1 by root 3 of f prime of 1 by root 3 from the given four options. That is the given question to us. Let us now discuss the solution of the problem in detail. We are given f, a differentiable function in the open interval 0 to pi by 2, and the integral cos x to 1 of t square f of t with respect to t is equal to sin cube x plus cos x. Agreed. Now differentiate with respect to x, and while differentiating the differential under the integral sign from the given limits, for that we use Newton-Leibniz formula for this on the left hand side. Let's look at the Newton-Leibniz formula, and the derivative is obtained as upper function 1 into t is equal to 1, you have to substitute 1 square f of t, and the derivative of 1 is 0. So 0 minus, for the lower function, cos square x, f of cos of x with respect to x, that is minus sin x. Agree? So that will be 0 minus cos square x, f of cos x with respect to x is minus sin x, is equal to the derivative of sin cube x, 3 sin square x cos x, minus the derivative of cos x is minus sin x. So we have used Newton-Leibniz formula. Agreed. Now minus into minus plus, and divide throughout by cos square x sin x. Then you will get f of cos x. F of cos x is equal to 3 sin square x cos x by cos square x sin x. That will be 3 tan x minus sin x by cos square x sin x is 1 by cos square x, that is minus secant square x. Agreed. Now differentiate both sides with respect to x. So f of cos x is equal to cos x derivative. First differentiate with respect to cos x, f prime cos x with respect to x minus sin x, into the derivative 3 is equal to 3 times derivative of tan x secant square x, minus the derivative of secant square x is 2 times secant x. The derivative of secant x with respect to x is secant x tan x then you will have minus 2 secant square x tan x. Agreed. Now divide throughout by minus sin x, because we want f prime of 1 by root 3. So we are trying to get to f prime of cos x now. Divide throughout by minus sin x. Then you will get f prime cos x is equal to 3 secant square x by minus sin x plus 2 secant cube x minus 2 secant square x tan x by minus sin x is plus 2 secant cube x. Now we want f prime of 1 by root 3. So put cos x is equal to 1 by root 3. And it's a very simple case. How to get sin x? You draw a diagram and then find the opposite side by hypotenuse and all that. Sin x is equal to root 2 by root 3. Right. We go and substitute. F prime of 1 by root 3 is equal to minus 3 into secant square x is root 3 whole square, that is 3, by sin x is root 2 by root 3 plus 2 into secant cube x is root 3 whole cube. That's equal to 9 root 3 by root 2 plus 2 into 3 root 3, that is 6 root 3. So we want 1 by root 3 f prime of 1 by root 3. So multiply by 1 by root 3. 1 by root 3 of f prime of 1 by root 3 is equal to 6 root 3 by root 3 is 6 minus 9 root 3 by root 2 by root 3, that is 9 by root 2. So that is the answer to this question. Let's look at our options. Our answer appears against option B. The answer to this question is option B. So that is the detailed discussion of the solution of the problem to find the value of the derivative of a given function. And before we conclude the video, I want to make a remark. So we make a remark here. That's our given question. And you take the given integral. So we have the integral cos x to 1 t square f t dt is equal to sin cube x plus cos x. Let's call this as the equation 1. Now this is not a balanced equation. In fact, this statement is not true. So we want to modify this one appropriately so that it will be meaningful. Now what we do is the interval is 0 to pi by 2. Let x tends to 0 from the right. So limit, note that limit x tends to 0 plus, that means x is tending to 0 from right, of the left hand side of this equation 1. That is 1 integral cos x to 1 t square f t dt. And if we take the limit will be from 1 to 1 only, integral 1 to 1 only, and thereby the answer is 0. Agreed. Take the right hand side. Limit x tends to 0 plus of sin cube x plus cos x is 0 plus 1, 1. So note now, as limit x tends to 0 plus, the left hand side is 0, the right hand side is 1. They are not balanced, they are not equal, and thereby this statement is not true. Right. So the given statement is not true. We want to modify that one so that the question 1 after modification is meaningful and it is a true statement. And what all we do is to get this answer, 1, what do we do? To get the, so what do we do? So the left hand side is 0, the right hand side is 1. To get the 0 only, the answer, from the right hand side subtract 1. So integral cos x to 1 t square f t dt is equal to sin cube x plus cos x minus 1. Now, as limit extends to 0 plus, this is also 0 and this is also 0. And thereby it will be meaningful, and it is, in fact, it is a true statement. It is a true statement. But sir, how is that we got the answer and we have proceeded? Yeah, this minus 1 doesn't take part when we differentiate both sides with respect to x. So we started with this, differentiate with respect to x, we said. So even if there is some constant, that will go off, and from there onwards everything is true. Everything is true. So, however, the next steps, as in the solution what we have seen in the earlier slide, will follow, because we started taking the differentiation on both sides. Therefore, this minus 1, even if it is there in the function, after differentiation, it will vanish and they will be equal. And thereby, we will be getting the answer also. However, there is no threat to the answer that we have arrived. So, this little modification is necessary, and perhaps the examiner might have forgotten, to put a minus 1 here, something like that. Something happened. So, that's what I wanted to say. So, this little modification we want to do. That's all for now. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.